Okay, we have Gary Griggs as our speaker today, and he's a distinguished professor of Earth and Planetary Sciences, and he's director of the Institute of Marine Sciences. He received his BA in geology from the University of California, Santa Barbara, and he has a PhD in oceanography from Ocean State University. He's been a professor of Earth Sciences since 1968 and director of the Institute of Marine Sciences and Long Marine Laboratory since '91. He was a Fulbright Scholar in Greece, spent a year there, I believe, and has conducted research in Italy and New Zealand. And in 1998, he was given the Outstanding Faculty Award in the Division of Physical and Biological Sciences. The Alumni Association honored him with a Distinguished Teaching Award in 2006. And the California Coastal Commission and Sunset Magazine named him as one of California's Coastal Heroes in 2009. And that was along with Pierce Brosnan and Julie Packard. And in 2010, he was named a Fellow of the California Academy of Sciences. Now, his research and teaching have focused on the coast of California, and they include coastal processes, the hazards, coastal engineering. He's had one full-time job, has sailed around the world twice, has 3 grandchildren, and I'll let you notice he says 3 grandchildren first before his children, which tells us something. Most of our grandfathers like that. Anyway, nobody got that. Yep. Has built 4 houses, has 5 children, has traveled on 6 continents, works 7 days a week on one thing or another, has written 8 books, and has used up all 9 of his lives with near-death experiences. But I checked with him this morning, and he's actually only on number 8. If he'd already used up 9, we would not have him here today. And so with that, Professor Griggs.
Thanks very much. Can everybody hear me okay?
Yeah.
Okay. So, well, I've worked with desalination. I've never given a talk on it before except in classes. And for those of you that have been around Santa Cruz any period of time, you probably understand well that as soon as any new issue proposal comes up, there's immediate controversy. Masks, vaccinations, desal is no exception. It's just the way we are in Santa Cruz. You put a line in the sand, you get on that side, argue about it for 10 years. In fact, they joke in Santa Cruz that you can tell the in-town developers from the out-of-town developers because those who live here are 10 years older because they've been waiting for their permit. So what I want to do is talk a little bit about water in Santa Cruz, drought, and then work into desal. So this is supposed to be the first slide. This happens to be the nation's now largest, newest desalination plant, which is down in Carlsbad, northern San Diego County. Any of you that read the local paper, it's kind of thin. You can do it in about 5 minutes usually. Somebody called me the other day, a friend said, I see they put 2 rubber bands on my paper to keep it from blowing away because it's so light. But I write this column, I've been doing it for about 8 years, called Our Ocean Backyard. And what I try to do is educate rather than advocate, to just provide information. And so desal I've been writing about for, I don't know, 4 or 5 columns, and it's tricky to sort of toe the line, but that's what I try to do. So certainly we all know Santa Cruz and all of California, all the West now is in a drought, one of the several driest 2-year periods in our history. A number of years ago, actually back in 2011, 10 years ago now, a couple of us were hired by the city to look at a sort of the vulnerability of Santa Cruz to climate change. The climate is changing. We don't get to vote on it. And how does that affect the city? So some of the things that we have seen coming and are likely, these relate directly to the city. The weather is getting hotter. Summer we're going to have more water shortages and longer droughts, probably more fires. This is a statewide issue, and more concentrated winter runoff and more flooding. And then we have things along the coast. Sea level is rising. We may get larger storm waves in the future, which would mean more waves attacking the cliffs, meaning the erosion rates of the bluffs will speed up. And then downtown, because we're very low and seawater seeps in, we'll probably be raising the water table, and we know seawater is intruding into coastal aquifers, which is a problem for Mid-County. And these are not new things, but what we're going to see is those happening more and more often. A book came out a couple of years ago by a couple of people from Berkeley called The West Without Water. And what it does is it goes into the history of drought in the West. And there's a number of ways we can actually document earlier climate periods. And this is this actually goes back over 1,000 years. One of the best signatures of previous rainfall are tree rings. Redwoods don't work very well. Redwoods don't reflect. They have ring changes, and when things are really good, like going to a nice big healthy lunch, our waistline goes out a little bit. The tree rings get bigger, and when it gets dry, the tree rings are narrow. So we have records that go back about 1,000 years, particularly in bristlecone pines that are down in the sort of southeastern part of the state. And we know there have been droughts that have lasted 20 or 30 years. But we didn't have 40 million people in California. We weren't the source of most of the nation's fruits and vegetables, so we're in a very different situation than we were 1,000 years ago. And these were a couple of those periods in years. AD 1021 to 1051 was a 30-year drought. So these are the things that give us some sort of perspective on what might be coming. This is the second year of a 2-year drought, and we've had 3-year droughts, 4-year droughts. This last year we had half of our normal rainfall. We have one reservoir you may know, Loch Lomond, and it provides, if we didn't use anything else, about a year of water. It's now, down to about 58%. We have a few other sources, mostly North Coast streams, but it's not likely to rain until probably November, December. So I think we should expect that the rationing level will go from 1 now, which is sort of be careful, here's your levels that you can use at your household. 2, you start to get fined if you go over that. You're going to pay more for that water. So the question's been asked, what's the difference between climate and weather? Climate's what we predict, weather's what we get. So climate is long-term over years and centuries. Weather's what we get this week or next week or this winter, and those are somewhat different. Just because it might rain tomorrow doesn't mean the climate has changed. It just means these sort of shorter-term aberrations. Sort of a rhetorical question: are these things we're seeing now, these droughts, are those a manifestation of global climate change, or can we take a day or 2 or a month or a year and project that and say, yeah, we're seeing changes? Everything we look at today tells us we're looking at long-term changes. There's an international group that just came out with their 6th report called IPCC, which stands for Intergovernmental Panel on Climate Change. It's run by the United Nations. They have about 600 or so scientists from around the world. Do you want to?
A little more direct for you.
Okay.
Like that.
Okay, good. That try to come to agreement, and in the past, the conclusions were sort of saying, well, we think humans have a role in it. It's probable that humans have a role in it. And this report that came out about 2 weeks ago said there's no question human activity is the big factor affecting climate change today. So the amount of water on the planet doesn't change. What is happening is more water is running into the oceans as the ice in Antarctica and Greenland and glaciers are melting. But the amount of water is fixed, and it moves through a cycle. Hydrologic cycle, it actually goes from the ocean or lakes or rivers, evaporates into the atmosphere. Water vapor rises, cools, condenses, and it rains or snows, and it runs back into the rivers and the streams and through groundwater back in the ocean. So there's this loop. And if we look at the distribution of water, about 97.5% of all the water on the planet is in the ocean, and it's salty. Not a lot, the equivalent of about 8 teaspoons of salt per gallon, 3.5%. But that's just enough to make it pretty much unusable for drinking or agriculture. So even though we've got a lot of it out there, we don't use too much of it. We use it for cooling, for power plants, and a few other things. Most of the rest of that, 100%, is in Greenland and Antarctica. So about 99.5% of all the water on the Earth is not immediately available to us. So the people of the planet use about 0.5%. That's what we're dependent on. So here we're dependent on San Lorenzo River, Loch Lomond, and a few coastal streams. Soquel Creek County Water District is totally groundwater dependent. So a lot of water out there, but not easily accessible to us. And if we look at the local area, if we just took a sort of a cross-section across the coast of Santa Cruz, it's very topographically dependent or elevation dependent. So if we're out on the coast, Santa Cruz, Davenport, 27 to 30 inches on average. Swanton, about the same, but as we get up to Empire Grade, the water vapor is rising, condensing, falling as rain. Bonnie Doon, Boulder Creek are more in the, close to 60 inches of rain, a little higher in Felton, Scotts Valley. By the time we get to San Jose, it's sort of a desert. 15 inches. You go to the southern part of the state, Los Angeles, San Diego, think they're in the tropics because they plant all these tropical vegetation and trees that they're a desert. They just import water from someplace else. So if we look at Santa Cruz City, and that's what probably many of us depend on, about 96% of our water supply is from surface water. Again, Loch Lomond, San Lorenzo River, and 3 North Coast streams. About 5% comes out of some small wells over in the Soquel area. So if it doesn't rain for a couple of years in a row, we don't have much water. Soquel Creek County Water District, on the other hand, is taking theirs out of aquifers, as does Scotts Valley and the San Lorenzo Valley for the most part. So those affect sort of what we have available to us depending on the most recent rains. And we, unlike many places in California, are totally dependent on Santa Cruz County. If you're in San Jose or San Francisco or San Jose, it comes from the Sierras. If you're Los Angeles, it comes from the Sierras and Central Valley. If you're in San Diego, some comes from the Colorado. Other than the bottled water that comes into your supermarket, everything comes out of Santa Cruz County. We don't have snowpack, so if it didn't rain, things start to get dry. So this is the historical rainfall for Santa Cruz going back to 1880. It's really hard to look at that and get any real pattern. You can see periods when it was drier than normal for a couple of years in a row, and then some really wet winters. And you can see these are some of the dry periods. There's no real definition of drought except below normal precipitation for maybe a year or two in a row. But it's really hard to read into that any trend yet. So the city has looked ahead. They prepare pretty regularly some kind of water conservation plan. I think this was 2017. and now there's a newer one. What this basically says is, when it gets to this point, this is what we're going to do, and begins to look into the future a bit. So how does our water get used here? 61% is for basically residences, single family, multifamily, and you can see it gets spread out between businesses in light blue, the university, municipal, parks and so forth, golf courses. But again, almost 2/3 is people in their homes. This never comes, well, you can see this, it's a little hard in an instant to get a view of what it is, but essentially this is going back to 1951, and there's a couple of different lines on here, but the top line in the little triangles is the population. The very bottom is rainfall. The triangles in the middle are actually the number of accounts or water meters or services. And then the red circles are how much water we're actually using. So what you can see is Santa Cruz has done an incredible job of reducing our water supply or our use as the population has gone up. So you've probably seen, if you're going to build a new house or rebuild a house, you have low flow fixtures in your toilets and your showers and your sinks. People were paid to take out their lawns. We're getting more and more conscious of it, and the city has encouraged that. So we've done a good job. We're actually using, less water now than, or about the same amount as we did back in the 50s. We can only conserve so much, however, and we still like to take showers and wash our clothes, so there's a limit to what we can do. So future options, how many do we have in Santa Cruz? Well, maybe God's in control. Maybe we fight about it, and actually we had something you may remember, depending on your age, probably not in this group, 1924. We actually had water wars as LA went up into Los Angeles, went into the Owens Valley area. They were stealing farmers' water. People were shooting at each other. They had called them the Owens Valley Wars. And then the last slide here on the right is a caricature, I guess a cartoon of desalination, although it's a little bit simpler than that. So about 15 years ago, a little longer than that, the then city water director, Bill Coker, realized we'd had droughts, we'd had rationing. We got to start looking ahead. If this happens again, what are we going to do? If it lasts longer, what are we going to do? So he initiated a plan to look at desalination for Santa Cruz. And they actually hired some engineering firms. I was running the marine lab at the time, and we had allowed them to build a small metal structure with pumps and pipes. Since we have seawater intake for marine mammals and the Seymour Center, it was an easy place to come and hook up to. I remember when we finished it and people came in and drank the water, and everything works out there. We can filter it. The reverse osmosis works. At about that time, a group sprung up in Santa Cruz, as typically does with any new issue that opposed it. I think they were called desal alternatives. And as any desalination plant gets proposed, there's typically 3 issues that get raised of concern, probably familiar to some of you. One is the cost, one is the energy, and the other is the ocean impacts. And we could spend a long time talking. We'll talk a little bit about each of those. So this group actually put a ballot measure out, an initiative, and people got to vote on not whether they wanted the plant or not, but whether they wanted the right to vote on the plant. In other words, do you want the chance to vote to see if we're going to build it? And about 2/3 of the people said, yeah, I want to vote on that. And this kind of raised an interesting question about local government. How many decisions do we leave up to the city council, the board of supervisors, and how many do we say we want to vote on that? So that was discouraging to the water department and the city water director, who'd been here 30 years. Some of you may have known him. I worked with him. Bill Coker. He said, I think it's time to retire. He retired. We brought a new water director. And through the city council, they set up something called the Water Supply Advisory Committee. Each city council member got to appoint 2 people, so there's a group of 14, some against it, some for it, some in the middle, representing every sort of possible group. They met for a couple of years. They had some engineering consultants, and they actually had a session down in the civic auditorium where the public could come in and say, well, why don't we do this? Why don't we do that? How about this? They came up with 100 alternatives. If you know Santa Cruz, there's not really 100 places to find water. They boiled those down to 4. 4 options for the future in this order. And part of this is remembering that this committee, a handful of those people were dead set against desalination. So the first was easy, more conservation measures. Doesn't cost anything until you can't conserve any longer. And you say, I'm sorry, we're shutting off your water today. And if you've been reading the papers, you know now the whole state is in a drought. Lots of farmers aren't going to get any water. Not a little bit, none. Some are getting less water. They're tearing down almond orchards and they're taking out crops. So it's serious. This isn't, fake news. It's real. But we only can go so far, and we're in our first phase of conservation now. And if you look at your water bill, I'm not sure everybody does. I mean, you pay it, it's okay. But it's tiered, so you get whatever. Typical family of 3 might get 150 gallons a day, and you pay at this rate. But when you go over that, it's more expensive per gallon. And you go to the next step, it's more expensive. So there's a price to pay. Capturing more surface runoff. We've got one big dam, we've got a few storage tanks, but we don't have any other place to store it. So even when it's raining, we don't have a place to put it. So one of the plans that's now underway, and if you drive down California Street between Bay and Laurel, there's been a lot of equipment there. They're putting a pipe in the ground. It looks maybe a 12, 14-inch diameter pipe. Now it's going down the Laurel Street Hill. It's going to go through town, across the river, down Broadway, all the way to Chanticleer and Soquel. They're going to treat the wastewater that the city generates to a higher level, pump it to Soquel, treat it to a higher level yet. They're going to pump it into wells along the coast to keep seawater from coming in, and hopefully store some of it in the ground so we can take it out later. We're not sure that's going to work, but this is over $100 million project. The next one was somehow to treat wastewater. Right now, well, we're all drinking wastewater. They say if you're on a river, the difference between living on a river, living on a lake, if you're on the lake, you're drinking your own wastewater treated. If you're on a river, you're drinking somebody else's. But so if you're in the San Lorenzo Valley, and we take some of our water from the river right down here, we're drinking treated wastewater that's gone through treatment and through the ground and so forth. So the idea here is you can't drink wastewater directly, but if we treat it to a high enough level, pump it back into the ground, can we then take it out later at a higher quality and use it? And that's not a done deal yet, but that's what this project that's now underway is sort of testing. What they are doing is pumping water from our drinking water treatment plant up on Graham Hill Road all the way to Soquel, putting that in the ground and let's checking the water quality. Does it change with the groundwater and so forth? And they put the last one, desalination. The biggest reservoir, that was the choice. So where do we go from here? I've always been looking for this sign, but I've never found it. So again, conservation, putting it in the ground, more storage, or this lower right is a desalination process down in North San Diego. So we've been desalting for a long time. I mean, probably over a century. Certain Pacific islands, for example, have built solar stills, and they have these on some lifeboats. Ships, most ships, Navy ships, cruise ships, don't keep all their water on board. They need it for fuel and other stuff. So they're constantly using the heat in the cooling water for their engines to boil seawater and condense it. So evaporation is historically the way we've produced most fresh water from salt water, because when you evaporate ocean water, you leave the salt behind. So you've got to condense that steam essentially and convert it to liquid. Freezing works when we make ice, like we do in Antarctica. As seawater freezes, the water molecules don't like salt in there, so they push the salt out. So the water around Antarctica is actually saltier. And we can do that in a contained system, but it's really hard to separate the slush and the ice and the water. So that has never proven to be very economically practical. So today, most of the new plants are all reverse osmosis, or we're pushing seawater, or we could do wastewater or brackish water through a semi-permeable membrane. This is sort of how our cells work, and we get fresh water on one side and the particulate matter and the salt and the bacteria on the other side. So that's the way all of the newer plants are being built. So around the planet today, we have a couple of thousand desalting plants. It produces water for maybe 300 million people, mostly in North Africa, the Middle East, places where it's really hot and dry and they don't have much water. A good portion of Israel's water, 40% of it is desalting seawater. But of that amount, it's only about 1% of the world's total drinking water. It's increasing, the amount of desalination, but it's still pretty small on a global level. So again, freezing, we can do it. It's not very effective. So we've sort of, it happens in the ocean, but we haven't used that commercially on land. This is what we used to do most of, and still maybe 40% is boiling. It takes energy. We got to use oil or gas. Saudi Arabia, a big chunk of their fresh water is made by distillation because they have a lot of oil. So we basically heat it up, boil it, condense the steam to fresh water, and then we can use it. One of the things that was originally proposed for Santa Cruz years ago, and a few other places, is to put a desalination plant next to a power plant, Moss Landing. We've already got water almost at the boiling point. We can use that water, heat it a little more, and we get steam. And what we're using mostly today is pushing it through these membranes that have been pretty well developed now, and that's what we used out at the Marine Lab that was proposed for Santa Cruz. It's basically, the energy is used is to push the seawater through these semi-permeable membranes. A fair amount of energy is required. If we use brackish water, say in an estuary or a lagoon that's not as salty as the ocean, or we're using wastewater, it doesn't take as much energy. So in many places we're using, say, water from an estuary or lagoon that might not be as salty as the ocean. So this is a plant that was completed in Cardiff, northern San Diego County, 2015. It produces about 10% of San Diego's water. San Diego is basically a desert. About 50 million gallons a day. That plant cost $1 billion. Sounds like a lot. But when you amortize that over time, sort of like buying in Santa Cruz, the cheapest house you can find is $1 million. And those are hard to find. You say, wow, I can't afford that. Well, you pay for it with a 30-year mortgage. You pay $3,000 a month or $4,000. You know, that's the way we do things. It turns out when that plant was first proposed 15 years earlier, it was going to be about $270 million. It took them 15 years from start to finish with plans, with lawsuits, with approvals, the Coastal Commission, and a lot of other organizations. So in the meantime, it had escalated from $270 million to $1 billion. It's been going since 2015. It's working, and now the same company, a private company, Poseidon, is right at the edge of approval for a second plant in Huntington Beach of the same size, about 50 million gallons a day. So the tech.
It looks as though it's not that physically big. Is that just the picture, or is that like, it doesn't seem like it's really enormous in size?
No, it's not that big, really. That's 50 million gallons a day. So depending on the size and therefore the capacity, it's going to take more or less room. So progress is being made. The technology, these membranes continue to improve. Plant efficiency is getting better. Costs are coming down. The discharge water quality is improving. So a lot of things are being done, as with any technology. I mean, look what's happening with cars. You can sleep in the back seat while your Tesla's driving you there, and then hope you don't die when it crashes into something. So in the U.S., we have about 1,400 desal plants. Most of them are modest in size. The one that was built in Cardiff is the biggest. Florida has the most, followed by California and Texas. Not a lot in terms of volume, 1.6 billion gallons a day, less than 1% of our entire U.S. water use. But it's growing pretty quickly. Again, we tend to use a lot of brackish water here if we can get it, because it doesn't take as much energy to push it through these membranes. So this looks complicated. It's really pretty simple. We sort of filter out the seaweed and everything else first. And to be clear, because there's a lot of concerns with the ocean impacts, which I'll talk about in a second here, we don't suck in whales and dolphins and fish. There's a screen on the intake, and we can make that screen as fine as we want. So essentially what comes through is plankton. But you filter out anything else at the beginning. It goes through some pre-treatment. Essentially, we then pump it through these tubes with these membranes in them. And ocean salinity is about 3.5% by weight. So in 100 pounds of water, there's 3.5 pounds of salt. About 8 teaspoonfuls per gallon. So if we take 100 gallons of seawater, we can produce roughly 50 gallons of fresh water and 50 gallons of what's called brine. So the brine is just double. If it's 3.5% in the seawater, it's 7% in that other half. To put that in perspective, because one of the issues raised is the brine, which sounds like contaminated water. It's twice ocean salinity, roughly. So a lot of reasons why we're going, some communities, for example, San Diego's going to desal. Populations are growing. And San Diego is now almost totally dependent on imported water. A fair amount from the Colorado River. And again, the Colorado River now is way oversubscribed. When we allocated the water, and I think it goes to some to Mexico, Arizona, California, Nevada, Utah, Colorado, they allocated it when we were in a very wet period, and now we don't have it. And if you've seen the pictures recently of Lake Powell and Lake Mead, they're down to 30%, the lowest they've ever been. So there's a dependency on the climate that is changing. We can't assume the climate's going to be the same, the rainfall is going to be the same next year as it was 50 years ago. So population is growing, per capita use of water in some places is growing. Santa Cruz, we're reducing that. These recurring droughts. So those are some of the reasons why cities are looking at desal. So this is the inside of that plant in Cardiff, these sort of tubes where the water goes through, push through these membranes. I won't spend a lot of time on it, but again, it took a long time, provides about 10% of San Diego's water. It took about 15 years to get it approved. So they said, any big coastal project meets with some public disapproval. Doesn't matter what it is. Could be, well, anything in Santa Cruz meets with some public disapproval. And we could probably make a list of the ones we're dealing with now. Although we're very different than other places in the country, I think we've done very well on vaccination, we've done very well on masks, but some states are in a very different situation. Do we widen Highway 1 again? Do we build more downtown high-rise? Does the university get bigger? Do we build a desal plant? People line up on both sides and then we argue about it. So the three issues I mentioned that were raised by this desal alternatives group was cost, energy, and potential ocean impacts. So the project that was proposed here roughly 15 years ago was to produce about 2.5 million gallons a day. Santa Cruz would jointly do it with Soquel Creek. They are groundwater dependent. We are surface water. And the idea was in dry winters when we don't have any stream runoff, we could use that 2.5 million gallons. And in periods when we've got surface water to use and their groundwater table has been drawn down, they can use it and recharge their groundwater table. So again, these costs, energy, some people have argued for growth inducement. It's going to allow us to grow more. I'm sure you've all heard of NIMBYs. Not in my backyard. Well, now there's a new one called bananas. Build absolutely nothing anywhere near anything. And we may have neighbors like that. We're here, we don't want anybody else here, and that's kind of something we struggle with. And then there's these marine impacts, and we'll talk about those. Stuff impinging on the screen as you pump in the plant, things that go into the plant, and then what happens when we put it back in the water. So to put the cost in perspective, Poseidon in San Diego is costing more than their present water. But if you don't have any present water, what are you willing to pay? One of the things that I think people have learned, or some people have learned, that an old friend who was on the city council for years and the mayor said the easiest thing that happens with every controversy is you draw a line and you get on that side and I get on this side and we fight it out with lawyers. He says what you really have to do is make a circle and put everybody inside. It's one city, it's one water system. And you can start by saying, what do we agree on? Well, we'd all like to have the water come on when we turn the faucet. I think that's not a controversy. I'd like to be able to wash my clothes and take a shower and wash the dishes and maybe have a little garden. Okay. Do we agree that maybe climate is changing? Well, I don't know. I don't know if that's happening or not. It sounds like a left-wing conspiracy to me or something. Anyway, we have that in Santa Cruz. So the cost in San Diego for desalinated water was about 2 times, or a little more than 2 times what they're paying, but it's guaranteed they can get it. If it doesn't rain or they get cut off from Colorado River water, they don't have any water. So they signed a 30-year contract, which enabled the company to build the plant. One of the challenges looking at cost estimates are, what are you talking about? So we can talk about different units, acre feet, millions of gallons, cubic feet. Is it at the plant or is it your house? We usually tend to think in terms of acre feet. So think about a football field covered with a foot of water. It's about an acre foot. roughly 326,000 gallons. And in Santa Cruz, that's enough for maybe 4 or 5 families for a year. So we often think about, acre feet. A little awkward. But I just looked at our water bill before I came over here, and it was something like $150 last month. $110. We met our volume. But in San Diego, the added cost to a homeowner's bill from that new desalination plant is about $8 a month to your water bill. Well, if you go down to Verve Coffee, you can pay $8 for a cup of coffee. So if you compare it to your internet bill or your television bill or any of your other bills, that's nothing. So it did cost $1 billion, but you're spreading that out over many years and many people. The other comparison that's often made is, well, that's more than we're paying now. Of course it is. Our system was built years ago. Loch Lomond was built back in the early 60s, and that's the last thing we built. Although right now, there are a number of different projects being done, particularly up at the dam, a new tunnel under the dam, pumps and other ways to improve the efficiency of that operation. This system of improvements does not add to the amount of water, but it's a total over 10 years of $500 million of improvements. The desal plant that was proposed 15 years ago was going to be $125 million. So that sounds like a lot, but for a big water department, they're spending 4 times that much just to improve our supply system. So anyway, it's hard to compare it with the present water cost because a lot of that was paid off years ago. So anything we do now to augment our power or our water supply is going to cost something. Are we ever going to build another dam? I don't think so. I don't think there's any place to put it. The city did buy wisely the Zayante Creek watershed years ago. They decided at the time not to build it for a number of reasons. Now it's, people live there. We just don't have a place to build a large dam. And dams are expensive. You may remember 2 years ago when the spillway on the Oroville Dam, the dam overflowed and the water started flowing down. Our local, now state senator, John Laird, was Secretary of Resource at the time, and he got very involved. Are we going to evacuate 125,000 people in case this thing fails completely? That repair of that dam cost $500 million. So building a new dam, you can imagine what that's going to be, compared to any other source of water. Desal begins to not sound so expensive. And a lot of our early water in California was paid for by the federal government. The Army Corps of Engineers built dams, Hoover Dam, so forth and so on, the Bureau of Reclamation. So we don't have that anymore. It's what can we do in Santa Cruz County. Energy, it takes energy. Everything we do takes energy. The comparison has been made between this proposed 2.5 million gallon per day plant that we were going to share costs in water with SoCal is about the equivalent of a moderate-sized hospital. I don't know whether Dominica is small or moderate or large. Maybe moderate. So think about how much it takes to run Dominican every day. That's about what the plant would cost. Or maybe a large indoor shopping mall. We have one of those on 41st Avenue. Personally, I'd rather have water than the mall, but it gives you a sense at least of how much energy it takes. Another comparison, the amount that fresh water from seawater for one household is less than your typical household refrigerator uses, just to put it in terms we can understand. So the environmental impacts from being involved in environmental issues over the years, one of the things any good environmentalist will do when you're opposed to a project is to use every single argument you can think of, whether it's valid or not, whether it's important or not, to stop it. This has been done with offshore wind projects, lots of other things. And you can hire a couple of attorneys too, which can slow down things. So the two main issues in the ocean, which are often brought up as the major stopping points, and I'm saying this as an oceanographer, is what's the impact of taking it out of the ocean, and what's the impact of discharging this salty brine back into the ocean. So intakes, again, can be of different sizes. We can put different screens on them to keep out things, and this is an example of one intake filter. I mean, you can't quite see it, but we have these on our intake pipes out at the marine lab because we bring in water for our aquarium and our marine mammal tanks. Pretty fine screen. The only thing that goes through that is plankton. You can also make multiple intakes, so all the volume isn't going into one. It looks like at the present time the state is requiring for any desalination intake that you actually put in wells on the beach and pump it from the seawater beneath the sand, which wouldn't have much plankton in it, or going out on the seafloor in a sandy layer, so we're eliminating or reducing those plankton impacts. There's another proposal down at Moss Landing, a group called Deepwater Desal, and most of the plankton, these are little diatoms, the bacteria, the small things that all the big stuff eats, is in the upper 150 feet because that's where the light is, that's where the diatoms and the plants can grow that the small animals feed on. And right at Moss Landing, you may know, we have one of the world's deepest submarine canyons. So we've got a place to put a pipe in that you could eliminate these plankton issues. But work that's been done, we've actually done some studies the city did out on the West Cliffs site area where the pipe might go in. They did plankton intakes for a number of months to see, and the percentage of marine life that was taken, these little plankton, was less than 1% of what was in the water. So it was a very, very small number. Interestingly, so this was going to pump in 5 million gallons a day. Moss Landing Power Plant has been taking in 1.2 billion gallons a day since 1960. It uses that to cool their condensers for the steam they make to produce the power. So the plant proposed here would be 0.4% of that. Very, very small amount of water. And we still have a fishing industry. We still have marine life out there. We don't see a big desert. So I just trying to put that in perspective. They did some studies there and found the amount of larvae and plankton and so forth that get taken. And it was like, in that small area, 400, 500 acres, was 13 to 28% of it. But it's a pretty small area that they looked at compared to the surface area of the bay, which is like 100,000 acres. So it's very localized, and it's very small from the studies that have been done. I'm not trying to sell you on it. I'm just trying to tell you this is what the studies have been done. Mitchell's Cove was where Santa Cruz did their study, and again it showed the entrainment for the one or two kind of fish they noticed was 0.02% of the larvae. And even something like crabs, they could find small amounts of those, and shrimp was 0.007%. Those are really small percentages. So when people say, well, it's going to affect the plankton, you can say, well, how much? Less than 1%. The other thing that is important when it comes to those little plankton out there, so the plankton are the larvae and the eggs of fish, crabs, squid. Most marine animals, in contrast to mammals that have one or two or whatever offspring, they have thousands. For example, a Dungeness crab can lay 2.5 million eggs. Less than 1% usually survive to adulthood, or we'd have crabs. That didn't sound very good. We'd have a lot of crabs down on the wharf for sale. I mean, you know, the industry kind of varies from year to year depending on the whales migrating. So on the order of a hundredth of a percent of most of those species' eggs ever grow to maturity because they're eaten by something else. So the plankton being taken in is, again, a very, very small percentage of what's out there. And then the brine disposal I mentioned earlier, after we take the salt out, in the case of Santa Cruz, roughly 2.5 million gallons would go back into the ocean with twice the amount of salt as it did when it started. Instead of 3.5% at 7%. There's a real simple solution, and people talk about brine disposal like it's radioactive waste or something. That's the way it reads sometimes. We have a wastewater treatment plant down in Nery's Lagoon, and we treat and use in our systems in the city about 7 to 8 million gallons a day. So that's what goes into the wastewater treatment plant, 7 to 8 million gallons a day. We treat it to secondary level. We pump it into a pipe that's a mile or so off natural bridges. And that's basically fresh water. Not drinkable, but there's no salt in it. So if we're worried about brine, we just take fresh water, we mix it with 7% salt, and we get saltwater salinity. So the brine disposal is, as an oceanographer, not an issue. You can raise that, it's just not an issue. The other thing you can do is, instead of putting out one big pipe with one big exit, you can put up diffusers. You put 10 of those up. I would say if you put 7% salt water in your home aquarium, I'm not sure the fish would like that over time, but the Pacific Ocean is not a home aquarium. We've got a lot of water out there, and it's moving around, and there's waves and currents, so it gets diluted pretty quickly. And where studies have been done, the effects are, unrecognizable. So direct ocean disposal is probably, in my view at least, is not an issue, and taking the water in is not an issue. The small effects we can reduce if we want to use multiple diffusers or smaller screens or whatever. So these are manageable. They will be raised. They have been raised by opposition. So just a few final thoughts. We've done this for decades. We can do it. It's not a technological issue. If anything, it's an emotional issue. We have a lot of information available from the plants that have existed for years, how they work, what we take in, what we put back out again. And as, again, droughts continue, populations grow in the coastal zone, prices are coming down. It's a very viable alternative. And I guess on the reassuring side, no matter what happens with droughts, we still have 97.5% of the world's water out there in the ocean, and we know how to desalt it. Right now, we don't have a plan B, or C, or D, or E. If the water runs out, we're up to our necks in yogurt, or whatever you want to be up to your neck in. We don't have another faucet to turn on. We don't have another place to get the water. So right now, anything we do, if we tried to start a desalination plant, restart it tomorrow, I doubt that we could get that online in less than 10 years just because of the permits and all the other issues. We're not going to build a dam. So I would just say desalination is a very realistic alternative. What we do in the city will be, I just met yesterday with somebody on the city council who wants to run for the board of supervisors, and she was asking me about desal, and I said, and typically many people just, if they're an environmentally oriented person, as soon as they hear desal, say, well, I'm against it. I said, do you like water? Do you want to turn your water on? Yeah. Well, tell me what we're going to do when the water runs out. So we need to be realistic about the future, and the ocean's not going away anytime soon. Okay, thank you very much. Of it. So the question was, we can talk about the effect of all the forest fire change on climate change, or the forest fire smoke on climate change. For me, it's more the amount of carbon dioxide that's going on in the atmosphere. And some of the numbers from last year's fires were, equivalent of all the cars in California for a year. So these are huge sources. We're burning fuel, which is no different than coal or oil or gas that's producing carbon dioxide. These are having big effects.
Where does the salt come from in the ocean in the first place?
Good question. So when the oceans first formed, we'll go back about 3 billion years. You guys remember that? It's just like yesterday. There was no ocean. The Earth was molten. It took a long time to cool it. Some atmospheric water was released as volcanoes and magma actually have water vapor. As it began to accumulate and the rocks on land began to weather and break down, that particulate matter dissolved salt, so there's magnesium and chloride and iron and copper and all those. Those are all going into the ocean. So if we went down to the San Lorenzo River today and we actually evaporated a gallon of water, we would find a small percent of salt in there. So the Colorado, the Columbia, the Nile, all those are putting in small amounts of salt, really small, because it doesn't taste salty. Over time, an equilibrium has developed at about 3.5%. So any additional salt is taken out by organisms, is taken out by clay minerals, it settles into the sediments. And we know from, like we can drill for water up in the San Lorenzo Valley, and there's what we could call old water that was there when those rocks formed on the seafloor that trapped some of that water. The salinity doesn't seem to have changed for hundreds of millions of years, so it's now in balance. But originally it's from weathering of rocks and minerals that have washed into the ocean through all those rivers around the planet. But it's now in balance. It's unfortunate it was not all fresh, but that's what we got. Yes?
Why can't we take the brine far enough way out into the ocean and release it and let it mix naturally with the ocean as it is, and dilute it to the point that it would be non-existent?
So, I mean, because it mixes so quickly here, we don't need to take it very far out. I mean, if we put it in with our present wastewater outfall, it's a mile offshore, and if you're on the beach, you're not going to notice it. It mixes pretty quickly here.
Just one more.
Charlie, you talked about doing this and you have this brine that goes out. But you have all these permeable filters and stuff that things are going to go through. What's cleaning those out? Or how do you reuse that stuff, or does it get disposed of? I mean, we have extra overhead that's not being shown.
There are a few chemicals that get added to keep things from growing on those filters and so forth, but I think it's like a swimming pool. You sort of back flush it, back out, so you clean off those membranes on a regular basis so you don't reduce their capacity really quickly.
Right, where does that go?
That's in the brine.
All in that percentage?
Yeah, so there are a few chemicals, but it's not like toxic waste.
Okay, I can tell that there are several questions, and we appreciate your
Sure.
them. Gary did say that he would hang around for a while, so why don't you bring your questions up? But I think that we need to wrap up for the group basically, so that those that need to leave for various reasons can do so. And so, but before we close down, is there a pressing question that we need to ask?
Yeah, I've heard you say it today, and I've read it in your...
Okay, can that be a question you ask him when you come up here?
Okay.
Yeah, because it'll be another 3-minute answer maybe.